Hi, everyone. So thanks for staying till the last presentation. And I just wanted to start by saying that I'm really grateful for being invited here and for the opportunity to speak to you, to the awesome Airflow community, which I'm really proud to be a part of. So my name is Szymon Przedwojski, and I'm a software engineer at Polidea, a Polish software house, the same one that Jarek, who spoke before, works at. And I came to you from our capital, the beautiful city of Warsaw. If you've never been there, I totally recommend it. And while you're at it, maybe drop into our office for a coffee. Who knows? So I guess you might be wondering why I came here like halfway across the globe to speak at a meetup. And I like to think that I'm a man on a mission, and I'm spreading the word about a great tool that Google actually started, and we at Polidea have been helping develop for the past few months. And the tool is the Oozie-to-Airflow converter. So it enables you to automatically convert XML workflows from Oozie to Airflow Python DAGs. Just like that. In goes an XML, out pops a Python file. Pretty cool, huh? I like to think that each time an XML file is made redundant, the world becomes a better place. So before I go into details of how the tool works and how we work on it, I just wanted to tell you why such a tool is needed. So who of you actually who of you knows what Oozie is? Okay, like 10 people. And who has used Oozie? Okay, pretty much the same people. So for the rest of you, just a quick info. So Oozie is a server-based workflow engine, just like Airflow. And it runs Hadoop, MapReduce, and Pig jobs. But it's not a general purpose workflow engine. It's tightly integrated with Hadoop. And it used to be a pretty popular solution in the big data ecosystem. So like I already mentioned, the workflows are defined in XMLs. And there are basically two types of nodes of which you can compose the workflows, control and action nodes. So there are 6 control flow nodes: start, end, kill, decision, fork, and join. And there are 14 action nodes like MapReduce, Pig, HDFS, etc. So all of them are tightly related to Hadoop. And to show you an example of what a workflow looks like, so this is actually an Oozie workflow with a single action, which is a shell action. And all it actually does is run a shell command, java -version. However, in Oozie, you also always need to have the start and end node, as well as the kill node to handle failures. So as you can see, for a simple command, it's pretty verbose. It's a pretty verbose XML, and this is what the visualization looks like in Oozie. So despite Oozie being quite used, there are many problems with it actually. So these include uninformative or misleading error messages, a bit dated UI, the confusing object model with all the workflows, coordinators, bundles, file property files. And the setup is pretty complex, as we also experienced when we set it up to do some system tests. And the XML workflow definition makes it hard to test, and it's itself rigid and verbose. The tool is limited to Hadoop, and it's pretty difficult to add custom functionality. So given all that, is Oozie as bad as the last season of Game of Thrones? Probably not as much, but still there are quite a few companies who want to migrate their existing workflows to Airflow. And most of you know Airflow, so why is it cool? Well, it has a modern UI. The workflow definition is written in a flexible Python. It is a general purpose workflow engine, so we can do a lot of pipelines. It's quite easy to add new functionality, either via plugins or new operators. And from what I found in one of the astronomer articles, actually, Airflow open source community is supposed to be 20 times bigger than the Oozie community. And last but not least, we have a cool logo. So the migration itself, it's not a trivial task. We know of at least one company which has to migrate 5,000 workflows. So imagine doing this by hand, right? I mean, it's a grueling job. So that's why we are developing this tool to make people's lives easier. So now you know why the tool is needed, and let's explore how it works. First, I want to mention that it's quite it's possible to migrate those workflows, because both Oozie and Airflow have this this concept of DAGs. So the workflows are directed acyclic graphs, and there are no cycles between actions. And this is a simple schema of how our tool works. So first, you input an XML file, and it's converter, which orchestrates the whole process. And it asks the parser to parse the file, and it builds an internal representation in the form of a workflow entity. And then, for each action in the workflow, there is a separate mapper which has the logic necessary to interpret each action, and it fills in the workflow with the appropriate data. And when the whole in-memory representation is ready, we feed it to a set of Jinja templates, which create the resulting Python DAG. So like I said, the core of the work is done in the mappers. So for each Oozie node, you need a separate mapper, and these are the ones that are currently implemented. It's not all of them, but most of them. And here you can see how we map each Oozie node to the Airflow operator. So these are the control nodes, and what's quite interesting and jumps out, I think, is that only 2 operators are needed for that. So for the decision node, we use the Python branch operator, and for the end node, we use the dummy operator, but only if there's a decision node upstream. And for the other control nodes, actually, we don't need any Airflow operator, because either we can use a specific trigger rule, or Airflow doesn't need an explicit start and end node, or it just runs concurrent tasks whenever it can. So this really simplifies the workflows. And for the action nodes, we do have to use an operator in each case. So we use, where we can, we use the existing operators dedicated for each type of action, like the Dataproc pig operator for pig. And where they are not available, we decided to use the just bash operators, and we have a pig job which runs a specific shell command or a custom shell script on the Hadoop cluster. So looking at this, you might notice that there is some sort of a limitation here, that we only support the Dataproc Hadoop installation for now. So that's a conscious decision, because in Airflow currently there are no generic Hadoop operators. So we decided to just use what's ready and available, and there are actually many Dataproc operators. So we decided to initially only support Dataproc, and in the future, when Airflow has more operators for other cloud cloud providers, or just generic Hadoop operators, then we'll give the user, for example, the choice which operator to use. So to better understand how everything works, let me take you on a journey of a workflow conversion. So first we have the same input XML, which I already showed you, the shell action. One thing I want to point out here is that this prepare node. So Oozie has this feature where you can, for most actions, you can define a prepare node, and it allows you to manipulate either create or delete some directories before the action is run. So this will be useful later. So first we have this workflow entity, and what's important here is that it has a set of relations and a dictionary of nodes. which are parsed. And for each node, each node has a dedicated mapper. All of them inherit from the base mapper, and the mapper will create the list of tasks and the list of relations between them. So in our case, it's a shell mapper, and each mapper has this toTasks and relations method, and it returns both lists. So in this case, you can see that we create a task which uses the template shell TPL, and if we detect if it has the prepare node, and then we also add the prepare task. So if there's no prepare task, one action node will be mapped to one task, and in the case of the prepare node, we will actually have two tasks, prepare one and the actual action. So the tasks and relation are quite simple classes. The task has an ID, the template it will use, the trigger rule, and the template params, which will be fed into the Jinja template, and the relation just joins two tasks together. And coming back to the prepare node, we have a prepare mix, and each mapper which needs to support it can inherit from it, and it allows you to create this prepare command. And what we decided to do is we have created a bash script which is uploaded to, in our case, to the GCS, because we use Composer to test our converted workflows. So we have this bash script, and we just here create a command, like a parameterized command to run it, and it talks to the Dataproc instance. So once all that is ready, we can finally render our workflow. The converter renders the workflow, and we use the templates. So this is the skeleton template, like the workflow template, and it lists all the dependencies, all the dictionary of parameters, which will be reused in the whole workflow. So we don't hard code the variables everywhere. We just like reuse them. And it defines the DAG. And for the DAG body, we have the separate template with all the tasks and relations between them. So in our case, it will be two templates, the shell template. And it, like I said, it uses the bash operator. And the bash command is actually a gcloud Dataproc job. So again, for now, limited to Dataproc. And the prepare template with the bash operator as well. So this is the result, and I hope you'll agree with me that it looks quite nice. We also format it with black before outputting it. So what we wanted to achieve really is to have the resulting Python file look like it was written by a real person, so that it's, because a lot of auto-generated code has this problem that it's hard to maintain, hard to extend, and we wanted to achieve the situation that you can really just take it and further modify it easily. So just to show you that's what it looked like before, the visualization from Oozie, and on the right you can see what it looks like in Airflow. Of course, this is a simple example, so to make it more interesting, this is like a more sophisticated example with multiple actions, and this is the Oozie version, and this is what it looks like after the conversion. All right, so let me now tell you where we are, because this project is an ongoing project. Like we haven't finished everything yet. So there are some limitations. Like for example, we only convert the workflow app, which is in Oozie actually the definition of the logic of the workflow. But the coordinator app, which defines the scheduling, is not yet supported. We've implemented 8 out of 14 action nodes, but like 1 or 2 of them are being reviewed currently. Some of the actions are supported with limitations, like for example, some configurations options might not be available as of now, but all the details are in the README. We don't yet support the expression language functions from Oozie, and we only support Dataproc. But there's a roadmap, and we want to implement the rest of Oozie actions soon, support the coordinator app, complete those EL functions, and support the generic Hadoop operators. So I also wanted to share with you how we work on this project. So it is hosted in GitHub, as all self-respecting open source project nowadays do. It's actually on Google Cloud Platform's account. And we use Python 3.6, Element 3 XML API for the XML, and Jinja templates. So quite simple here in terms of technologies. But we have quite advanced automatic checks. So we have a pre-commit hook, which uses linters and auto-formatting, inserting licenses, checking typing annotations, etc. So we do this to actually avoid pointing out simple mistakes to each other in code reviews. So we want to automate as many checks as possible, and we have that running locally on our machines as well as in Travis. The code coverage is quite high, 96%, and we want to keep it that way. And I like to say that we have quite nice code quality. So I actually use this tool, LGTM, which supposedly like evaluates open source projects in terms of code quality. And we got an A, so I guess Uncle Bob approves, right? However, it also gave us A+ for JavaScript, and there's no single line of JavaScript in there. So I'm not sure how reliable this is, but hey, we got an A. So yeah, I got to go with that. One more thing is that we have also quite a robust framework for end-to-end system tests. So with one line one line command, you can actually do a conversion of multiple workflows and get them to run on Oozie and at the same time on Airflow. And actually, for now, manually compare the results, but we want to also do that in the near future, that the results are compared automatically. So you can actually see if the conversion is okay, if the results on both workflow engines are the same. So why am I telling you this? It's my main point here is to show you that the code base is really quite clean, concise, and coherent, and easy to jump into, and hard to break things. And that's because actually we want you to help us. If you are interested by this, we have the call for contributions. So there are many ways in which you could contribute to this project, either just by trying out the tool and possibly creating some issues in GitHub, or even sharing your Oozie workflow if you have some real life ones, so that we can actually have all the real life corner cases covered. Of course, you can also help with the tool development directly by contributing, or even by just improving documentation or adding some tests. However, there's also a second way in which you could help us. So if you already are an Airflow contributor or want to become one and are looking for something to start working on, it would be actually awesome if you could work on those generic Hadoop operators. If they were added to Airflow by the Airflow community, this would also help our project. So a win-win, I guess. So with that, I want to finish by telling you where you can find this project. So of course, we're on GitHub, and here's the link. But also, thanks to Jarek's effort, a very early version is on PyPI, and you can actually do pip install O2A. How cool is that? So I hope you enjoyed this talk as much as I did delivering it. And with that, thank you. Any questions? Yeah?
So knowing Oozie pretty well and like trying to convert, are there features or semantics in Oozie workflows that you wish were in Airflow? Or like some cool features that you can't translate because there's no equivalent directly?
Okay, so full disclaimer, I've never used Oozie in production, actually. So my only experience is with running some example workflows for the purposes of trying out the tool and those tests. From the top of my head, not really.
That's the right answer.
Airflow is awesome. So we don't need anything else, right? Okay, if there are no more questions, then I guess I can pass the mic. Thanks.